If an interviewer asks you to design a Terraform Mono-Repo for 20 AWS accounts, and your first answer is use Workspaces, you just failed. By the end of this, you'll be able to walk an interviewer through a production-grade Terraform Mono-Repo design for 20-plus AWS accounts. Folder structure, state strategy, provider config, CI/CD, and the gotchas that take down real platform teams. This is the kind of answer that gets you the offer. Here's how it gets asked. Your platform team manages 20 AWS accounts, dev, staging, prod, and several product team sandboxes. All infrastructure is Terraform. How do you structure a single mono-repo so one engineer can safely deploy to one account without touching another? Walk me through the design. That's the full prompt. It's deliberately open-ended. They want to see how you think about isolation, scale, and team safety, not whether you know a specific CLI flag. Here's why this question actually trips people up. The naive answer is, put everything in one folder and use Terraform Workspaces, one workspace per account. Workspaces share state backends, they share provider configs, and a bug in your state file can corrupt multiple accounts at once. That's not theoretical. It's a classic failure pattern on real platform teams. The real challenge is threefold. You need state isolation per account, so a corrupt or locked state in account A cannot block account B. You need provider configuration that authenticates independently to each account using role assumption. And you need a CI/CD system that can figure out which accounts were actually touched by a given pull request and run plan, and apply only for those, not a full 20-account plan on every merge. These three problems drive the whole design. The folder structure is the foundation. At the root, you have two major directories, modules and accounts. The modules directory holds reusable building blocks, things like your VPC module, your EKS cluster module, your IAM baseline. These are pure Terraform modules, with no backend config and no provider blocks. They just define resources and expose variables. Then you have the accounts directory. Inside it, you create one subdirectory per AWS account, named with something human-readable, plus the account ID, like prod 123456 or sandbox engineering 78902. Each of those account folders is a completely independent Terraform root module. It has its own backend .ef pointing to an S3 bucket in that account, its own providers .tf that assumes a deployment role in that account, its own variables and tf-vars files, and it calls the shared modules from the modules directory using relative paths or a module registry. This is the key insight. Directories are your isolation boundary, not workspaces. Let me show you what the provider and backend config looks like inside one account folder. The backend.tf specifies an S3 bucket and DynamoDB table that live inside that AWS account. So the state file for prod 1111 lives in an S3 bucket owned by account 111111. Nobody else's Terraform touches that bucket. The providers.tf uses the AWS provider with an assumed Josh role block pointing to a deployment role in that account. Something like arn.dws, diam, role, Terraform deploy role. In CI/CD, your runner authenticates to a central account using OIDC, your OpenID Connect federation with GitHub Actions or whatever your system is, and then assumes the per-account role from there. This means each account's Terraform execution has its own credential scope. A misconfigured plan in Sandbox can't accidentally assume the prod role because the role ARN is hard-coded per account folder. Here's where most answers fall short. CI/CD. If you run Terraform plan across all 20 accounts on every pull request, you have two problems. First, it's slow. 20 plans in serial can take 10+ minutes. Second, a failing plan in one account blocks all the others. The right approach is changed path detection. In GitHub Actions, you use a job that runs git diff to identify which account subdirectories were modified in the pull request. Then you build a dynamic matrix of only those accounts and run plan against each in parallel. Atlantis, the pull request automation tool for Terraform, does this natively. It has a project configuration where each account folder is a separate project, and it only plans projects touched by the diff. You also want separate approval requirements per environment tier. Sandbox accounts auto-apply and merge. Staging requires one approval. Prod requires two, and ideally a time-gated merge window. One more piece of the implementation that interviewers love to probe. How do you version your shared modules when they live in the same repo? You have two options. Option 1 is relative paths. Accounts reference modules via something like source.c class modules RVPC. Simple, but every account always uses the current main branch version of that module, so a breaking change in the VPC module immediately affects every account that gets deployed. Option 2 is tagging the modules and referencing by git tag or a specific commit SHA. You'd use source pointing to a GitHub URL with a ref parameter. Then you use something like RenovateBot to open pull requests when new module tags are published, and each account team opts in to the upgrade on their own schedule. For 20 accounts with different risk tolerances, prod versus sandbox, option 2 is clearly safer. The cost is the overhead of managing tags and reviewing upgrade PRs. Interviewers will push back on the directory approach and ask, why not just use Workspaces? Here's how you answer that directly. Terraform workspaces are stored in the same S3 bucket under different keys. They share the same backend configuration, the same provider configuration, and the same variable defaults. If your provider config has a bug, wrong role, ARN, wrong region, it affects every workspace simultaneously. And workspace selection is a manual step that's easy to forget, which means a distracted engineer running Terraform applying the wrong terminal can hit the wrong account. Directories eliminate that entire class of mistake. Each directory is an independent root module. There's nothing to select. You're either in the prod folder or you're not. Workspaces do have a legitimate use case. Short-lived feature environments within a single account, where you want 10 near-identical environments from one config. But for account-level isolation across 20 accounts, directories win every time. Here's the gotcha that separates people who've actually run this at scale from people who've only read the docs. With 20 accounts, someone will inevitably make a manual change in the AWS console. Maybe a security team patches a security group directly. Maybe someone adds an IAM policy in an incident. Your Terraform state is now drifted and you don't know it. The first time you find out is when an unrelated PR triggers a plan, and suddenly you have unexpected diffs in prod. That surprises are never fun at 2 p.m., let alone during an incident. The fix is scheduled drift detection. You run Terraform plan with the detailed exit code flag on a nightly schedule across all accounts. Exit code 0 means no changes. Exit code 2 means drift detected. You alert on that and open a tracking issue. This is not Terraform's default behavior. You have to build it explicitly. Most teams skip it until they get burned. The insider tip that makes your answer sound genuinely production-hardened. How do you bootstrap account number 21? Before Terraform can run against a new account, the S3 bucket for state and the DynamoDB table for locking need to exist in that account. But you can't use Terraform to create them, because Terraform needs them to already exist. It's the classic chicken and egg. Teams handle this a few ways. Some use a minimal CloudFormation stack, ironic but practical, that creates the S3 bucket and DynamoDB table as part of the AWS Control Tower account enrollment process. Others have a dedicated Bootstrap Terraform root module that uses a local backend to create just those two resources. And once it runs successfully, you migrate to the remote backend. Whatever approach you use, document it. The worst thing is, account 17 was bootstrapped differently from account 18, and nobody remembers why. Here's the answer in one pass. Use directories, not workspaces, as your isolation boundary. One folder per account, with its own backend and provider config. Modules live in a shared directory and get pinned by git tag, so accounts can upgrade independently. CI/CD uses change path detection to run plans only against touched accounts, with tiered approval for sandbox versus prod. Drift detection runs nightly on a schedule. And you have a bootstrap process for new accounts that handles the chicken and egg state backend problem. That's an answer that covers the what, the why, and the failure modes, which is exactly what a senior interview is testing for. Once you've landed this answer, the interviewer's follow-up is almost always, have you heard of TerraGrunt and how does it compare? TerraGrunt exists specifically to remove the per-account boilerplate we just wrote. The repeated backend.tf and providers.tf files across 20 folders. If you want to be ready for that follow-up, the TerraGrunt multi-account deep dive is the exact next video to watch. It picks up right where this one ends.